Okay, in this video, we're going to be getting started with solving polynomial equations, okay? So let me just give you where we're going with this. Let me get a new blank document. Okay, so we're going to be learning how to solve a polynomial equation where the degree, is bigger than 2. You already know how to solve something like this, and you already know how to solve something like this, but our focus is going to be on, well, what do we do if it's x to the third plus 3x squared minus 4x plus 1? What if it's something like that, or even an x to the fourth or an x to the seventh? Okay, and the exponent is the degree of the polynomial, so it tells you how many solutions to expect. Okay, so if it's degree 3, there'd be 3 solutions I'd be looking for. If it's degree 4, I'm looking for 4 of them. So that's where we're going, is we're learning how to solve a polynomial equation. So you already have a lot of the skills that you need. In fact, these are polynomials. You already know how to solve those. Okay. And then what we're going to do when the degree is higher than 2 is we're going to figure out how to break them down into equations that are either linear or quadratic. And so you need to be good at solving the quadratic equation. So there's 2 skills needed, 2 skills. You needed to know how to solve a quadratic equation. So you need to get back up to speed on quadratic formulas and factoring. And then the other one is to be able to do division quickly. So we're going to be learning this synthetic division, and that's the focus of this video. If you can do those 2 skills quickly, you'll be home free, okay? So synthetic division is the process that you can use instead of long division. I don't know if you remember way back when we did long division, but it was not everybody's favorite thing. So like if I'm trying to divide, let me go ahead and just pull up some problems that we'll work through. If I'm trying to do problems like this, if I'm trying to just do a division problem, it can be written using a fraction bar or the regular division. Okay, and let me snip those. Synthetic division can be used to do this, to save you a lot of time. So what you do, whatever you're dividing by, so that's this, okay, tells you what should go into the box. Okay, now if x minus 5 is there, then 5 goes in the box. Okay, so 5 goes in the box, and then you take the numbers that are the coefficients and you put those down, and see how it went 3, 2, 1, none. So you didn't have any missing ones. And then you wind up doing your synthetic division process. So that's what I'm teaching you in this video. So here's how it works. You bring down the first number and then you multiply and write it there. Then every time you're going straight down, you're adding. So negative 18 and positive 20 is 2. Then you multiply 5 times 2, that gives you 10. Then negative 4 plus 10 is positive 6. Then you do 5 times 6, that's 30. And then you do negative 30 plus 30, and you get a remainder of 0. Okay, so what happens is this 5 corresponded to the x minus 5. Okay, this was the 4x to the third minus 18x squared minus 4x minus 30. Okay, so instead of doing that kind of long division we would have done, okay, what we can do is say, all right, if I took and I divided a cube by an x, then this down here is going to be 4x to the second plus 2x plus 6. All right, and this would be your quotient. So it'd be 4x to the second plus 2x plus 6. And there was a remainder of 0, so you didn't have to have the rest of it. Okay. All right, now look at this one. This one you're dividing x plus 7 into the x squared plus 13x plus 38. So that means you're going to have the x me change color so you know which goes with which problem. Okay, so you're going to have your x squared, your 13x, and your 38 there. What's going to go in the box, since that was x plus 7, what goes in the box is the root or the 0. So that would be -7. Not the factor, but the root or the 0. Okay. All right, so then we're going to come in here, and we're going to bring down the first number, and then multiply. Okay, and here we get a -42, and then that gives us negative, what is that, 4? Yeah. All right, and so then this right here is your remainder. This right here is where your quotient comes from. Okay. All right, so I kind of think about these problems like I'm changing from an improper fraction into a mixed number. So like if I were dividing 6 by 2, it would go in there evenly. That's what happened on number 1. What you were dividing by, they were x minus 5 was a factor, so it divided evenly. But if I had 7 divided by 2, and I did that, go in there 3 times with 1 left over. So that would be 3.5. Okay, and see that's what we're learning how to do. We're writing the answer, and so sometimes you're going to have, a mixed number, and see how it's what's on top is 3, and then it's the remainder over what you were dividing by. Okay, so what happens here? This quotient. This is the quotient. And then that's where the remainder goes. Okay. And then right here is your divisor. Okay. And see where that is. That's on the bottom. All right. So this winds up being then, since this was an x squared and we were dividing by an x, this is going to be an x. So we wind up getting x plus 6 plus -4 over what we were dividing by, which was x plus 7. So if they're asking you to divide using synthetic division, it's written as the quotient plus the remainder over what you were dividing by. Okay, so let's try this guy. So this one's a good example to catch this little issue that can happen. X plus 2 corresponds to that's a factor. X plus 2 corresponds to a root or a solution of -2. Then we take the coefficients here, but you see how it went 3, 2, and it skipped just the x term? When you go to do this, you need to put the 1, the -1, then you have a missing spot, and then a 5. So that placeholder is important because it was missing the x term. So you're going to fill in with a placeholder, kind of like when we did long division way back in a previous class. So bring down the 1, multiply, goes there. Every time you go straight down, you're adding. So that's -3, multiply, add straight down, get a 6, come back over here and multiply, add straight down, we get a -7. So this one turns out to be then, this is the quotient. And see how there's 3 numbers? So that's going to be x squared minus 3x plus 6 plus your remainder over what you were dividing by. Okay? All right, now most of the time we don't use synthetic division just to do division. We use it to answer another kind of question. Okay? All right, so let's go ahead and take a look at other things you can be asked to answer. So let me go back to the worksheet. Another thing you can do with synthetic division is you can find the value of a function. Okay, so let me snip that. Okay, so there's a theorem called the remainder theorem. So synthetic division is a tool that can answer this question for you. It can help you to find the value of the function at -3. So you put -3 itself in the box, not +3. You put -3 itself in the box. Okay, and then you put the 2, the -7, the -5, and the 12. See how all the terms were there, and I made sure to include positives and negatives. Now you do your synthetic division. So you bring down, then multiply, add as you're going straight down, and then multiply. And these can get big. Add as you're going straight down, and then multiply. Okay, better do that on my calculator to be sure. 34 times 3 is 102, and it would be -102. So then I'd get a 90 right here. And this right here, the remainder, is the value of the function at -3. So f of -3 equals 90. And that's almost faster than you plugging in a -3 in here and working it out. Okay, let's try another one. If I want f of 1/2, I can put 1/2 in the box. I have to watch out on this one. It has a cube, a squared, an x, but then it's missing the constant. So make sure you add that 0 at the end. You have to make sure you have all the terms there. And if one's missing, you put in a 0 as a placeholder. So bring down the 4 and multiply. Half of 4 is 2. Add straight down. You get -2 and multiply. Add straight down. Get -8 and multiply. And then add straight down. Okay, and I get a -4. So that tells me that f of 1/2 should equal -4. And when you get really good at synthetic division, you can do that really quickly. Now, of course, that's what you would get, should be what you would get if you plugged in 1/2 everywhere. It's just that's not necessarily as easy as doing the synthetic division real quick. Okay, so you could do it, and you should get the same thing, but the whole point of this was all the different things that synthetic division can do for us, and we can do it quickly. All right, now on this one, it's asking us to determine if the second polynomial is a factor of the first, okay? Is a factor of the first. So you need to know what goes in the box. And so if you're given a factor in one of the videos, and some of you are going to watch it before you do this video, but some are going to watch it after, the x minus 3 is the factor, and what goes in the box is what would happen if you set that equal to 0. So if x minus 3 is the factor, then I would put 3 in the box. And then I would look here, I have a cube, a squared, an x, and a 15. So there's no missing terms. I just write those down. Then I'm going to bring down the 1 and then multiply. Okay, so bring down that, then multiply. Then add straight down, then multiply. Add straight down, then multiply, and then add straight down. Okay, and then if you wind up getting a 0, the answer is yes. It is a factor because there was no remainder left. So since there was no remainder left, then that means the x, when I did the division, then that means x minus 3 divides into that polynomial evenly. And so your answer would be yes, okay? All right, now, if it starts out as an x plus 2, if you were to set it equal to 0, that would be a -2. -2, what goes in the box is the root or the 0, okay? So if you're starting with a factor, you have to find out what should go in the box. All right, let's see, there's no missing terms, so I don't have to worry about a placeholder. Bring down the 5, then multiply. Add straight down, get a -2, and then multiply and write it there. Add straight down, then multiply and write it there. Okay, oh, so this one also wound up being 0, so the answer would be yes. Okay, the answer can be no. If you get anything other than 0, the answer would be no. Okay, so there's 2 other things that synthetic division can do. And we're really just trying to get some practice with synthetic division. All right, let me go ahead, though, and look at the 3 most important ones. Okay, this is the real reason. Let me put a little asterisk here. Oops. Let me snip it and then put a little asterisk on that. This is the real reason we're doing it. This is helping us with what we're trying to ultimately do. Okay, we're really trying to be able to solve a polynomial equation. Okay, so these questions are the ones we're really trying to answer. So this says use synthetic division to decide whether the number given is a root or zero of the polynomial equation. So see how we have a polynomial equation here asking us if 3 is a root of that. For 3 to be a root of that, it has to make it true. So when you plug a 3 in, you should get a 0. So you could test it that way, but we're being told to do synthetic division. So the root or 0 itself goes in the box. You don't write the negative of that, just 3. You write down the terms, but notice this went from 4 to 2. So don't forget to put a 0 in. This was the x to the 4th term. This is the x to the 3rd, and it was missing. Then we have x to the 2nd, x, and a constant. So I'm going to bring down the -1 and multiply. Okay, and put it there. Bring down the 0 and -3 would be -3, then multiply. 8 and -9 is -1. Then -3 and -1 is -4. And then that gives me -12. And that's supposed to be 0. If this were a 0 of the function, then the remainder should be 0. So it's not 0, so my answer would be no. Okay. All right, let's try the next one. Testing whether 1/2 works. Okay, so on this one, I have a 4th, then the cube, and then I'm missing the squared, and then I've got the x, and I've got the constant. So I'm going to bring down a 2, then multiply 2 times 1/2, I get a 1. Gives me a -20. Then I multiply 1/2 of -20 is -10. Okay, so that's -10. And then 1/2 of -10 is -5. Okay, and I add straight down. These get added as you go straight down. And then 1/2 of -2 is -1. And that time I did get a 0. So yes, 1/2 is a root. Actually, 1/2 is a 0, and I would use the term 0 for the function. And 3 is a root of that polynomial equation. Okay. All right, and then on problem number 10, this is kind of why we're doing it. So here they're asking us to actually go through the whole process. So it says solve the equation given that 3 is a 0. So you set it up. So you say 3 is a 0 of that function, so that means 3 is a root. I'm going to put those numbers in there. I'm going to wind up using my synthetic division. Don't forget to bring down that first number. Then you multiply, add straight down. Then you multiply, add straight down, and then you multiply. And this needed to be 0 because 3 was a 0 of the function. So it's supposed to give you a remainder of 0. Now here's the concept. Okay. So what we wind up doing at this point is using the fact that if 3 is a 0, that means x minus 3 was a factor, and that this is the other factor, 2x squared minus 11x plus, that's a 5, plus 5. See, it's got 3 things left, so that's the other factor. So it means my original polynomial that I had that I was trying to solve can be factored into x minus 3 times 2x squared minus 11x plus 5. And so this is just a linear and a quadratic equation. See, I know I can set those equal to 0, just like I did when I was solving quadratics by factoring. And then I'm going to try to break this up, if I can, a little more. I'm going to work on it a little bit. Oh yeah, I think it will work if I use a 5 and a 1 and make them both negative. And so then I'm going to solve that equation, and I get x equals 1/2. And I'm going to solve this equation, and I get x equals 5. So that's kind of where we're going with it, and that's what the video on solving polynomial equations does. This just went back and kind of focused on synthetic division itself, okay? And so we knew 3 was a 0, and then we just found the other zeros would be a 1/2 and a 5, okay? All right, so